It's Thursday, 18th of July 2024, and welcome to the Water Action Platform. I'm Jo Burgess, and this month I have a delicious buffet of topics for you. Variety is the spice of life. Today we will be looking at how science fiction is intertwined with science fact, at how the stark contrast of one woman's privileged childhood compared to the world she saw around her led her to become a force for water justice, and at hydrothermal carbonisation, a technology that sounds like science fiction but is very much science fact. Then finally, Piers Clark is going to talk about what he thinks we should do about poo, because of course he is. All of this is of course only possible because of our incredible sponsors listed here, and I thank them. First up, my colleague and friend Dr. Reshmina William is here to talk about the movies. Dune Part 2 is an American epic science fiction film released earlier this year to critical acclaim. It's the second of a two-part adaptation of a 1965 novel, Dune, by Frank Herbert. Anyone who's watched it will recognise these clothes as still suits, moisture-harvesting suits for desert survival. So how realistic, how futuristic was Frank Herbert's thinking nearly 60 years ago? Well, Reshmina is a water expert at Isle and a wonderful sci-fi nerd, so who better to ask?
Hi everyone, my name is Dr. Reshmina William and I'm a project manager with the Isle Americas office. I'm also an unmitigated nerd, which is why I've been asked to talk to you all today about Dune and the science of still suits. Before I jump in today, I first want to acknowledge that I originally gave this presentation at Phoenix Fan Fusion earlier this year through the annual science programming offered through the nonprofit Real-Time STEAM. Sci-fi and fantasy is a wonderful on-road to STEM for the general public, so it's a great way for us as scientists and engineers to share why we love what we do. With that out of the way, I'll get off my soapbox and let's talk shop about water, and specifically about water reuse. So why reuse water? The point of the matter is that water is heavy. It's bad enough here on Earth where we have more than enough water to go around. It's just very badly distributed. That means that we have to spend a lot of energy to pump it from a river or a reservoir or out of the ground, and then treat it, and then send it off where it needs to go through thousands of miles of pipes. Imagine how much worse it would be if you need to pay to launch all the water you needed into space. This is one of the reasons why folks like NASA are at the forefront of water reuse technologies. It's because those are the types of environments where it's especially needed. So when I talk about water reuse, I always like to talk about making it fit for purpose, which basically means making your source match your end use. There are many different sources that we can take reused water from. We can get it from rainwater. We can get it from gray water, so the water that's coming out of your shower or down your sink. We can get it from black water, the water that you get when you flush your toilet, or from storm water, which basically means rainwater that's hit the ground and run off, picking up any contaminants associated with that runoff into our storm sewers in our urban areas. And different source waters contain different contaminants that need to be removed. So that could be things like fecal pathogens or environmental pathogens, things that grow inside our distribution system, for example, like Legionella, or heavy metals like lead, nutrients like nitrogen and phosphorus, herbicides and pesticides, and so on and so forth. Then we need to consider our end use. You could be using water for irrigation, either for food or for non-food purposes. You could be using it to flush your toilet. You could be using it to wash your clothes. You could be using it in an HVAC system or as drinking water. And all of those different end uses have different levels of exposure and different exposure pathways to different types of contaminants. So, for example, if you're in a swimming pool or using water to water your lawn, you might be coming into physical contact with the water and be exposed to it through your skin. If you're in the shower, you might be drinking it, you might be breathing it in as an aerosol, or you might be drinking it or ingesting it with your food. Linking source and use together gives you your level and type of appropriate treatment, which could be physical or chemical or biological. All different types of treatment treat different types of contaminants and require different levels of energy and produce different byproducts. I've talked a lot about how water is used and reused here on Earth, but what about Dune? What about still suits? Well, we actually have a lot of the practical technologies that would make a still suit run, so I'll walk you through some of them. First things first, still suits need to be able to recycle the water from the human body, recycling of moisture from sweat, breath, urine, and feces. And we're already doing this on the International Space Station, which I'll get to in a couple of slides. So we have the technology to do that. Still suits need to have an in-unit portable treatment system and the ability to store the water that's treated. Now, the problem here isn't that we can't make the in-unit processes small enough. We actually have the technology to do that. The problem is, remember, water is heavy, and human beings produce a lot of it, between 1.5 quarts per day on a good day, and 1.5 quarts per hour if you're out there on a very hot day doing physical exercise. And all of that liquid needs to be stored and carried around. Water weighs about 1 kilogram per liter. So that's a lot of weight to be carrying around with you. The third challenge for still suits is maintaining a low level of humidity to allow physical functioning. Many of the treatment processes that I've talked about previously require physical evaporation. And so it's a tricky balancing act to maintain a suit that's waterproof, so you're not losing that water to the environment around you, but also allows the treatment processes to function in such a way that you won't kill the human being inside the suit via suffocation. However, the real challenge to creating a still suit in real life is figuring out how to create a self-contained source of power. If you look at the way that still suits are powered in the books or in the movies, they rely on the energy of the human body to treat water. So that's the kinetic energy you create by moving around, or your body heat. And despite the advances in treatment technology we've had over the years, we're not quite there yet. However, I do want to note that we're actually pretty close to achieving the impossible. This picture is taken from the International Space Station, and the instrument that this astronaut is holding up is called the Environmental Control and Life Support System, or ECLSS, because NASA loves its acronyms. And it actually captures the bulk of the water that's used in the ISS, and it's made up of 3 main components. The first is the water processor assembly. So this is the processor that's responsible for capturing moisture from the air that comes from our breath or sweat. And it's also responsible for the purification of wastewater. Secondly, we have the urine processor assembly, which distills urine on board and creates reusable water and brine as a waste product. And finally, we have the brine processor assembly, which takes that waste brine and extracts any remaining water from it. What this means is that when you put these 3 processors together, you have 98% water recovery, which is pretty incredible. It means that for every 100 gallons you send up to the ISS, you're actually reusing 98 of those gallons, which is pretty incredible. I wanted to end with a socioeconomic construct, which is the fact that water is undervalued until it isn't. So a common theme in economics is what we call the diamond water paradox. And this is an illustration of the difference between value and usefulness. We use diamonds for very few things, but they're clearly very expensive and very highly valued. Conversely, we use water in almost everything, but the cost of water in most places is so highly subsidized as to be almost negligible, a factor that has partially contributed to the US's crisis of failing water infrastructure. And while part of that discrepancy has to do with what's known as marginal value, in other words, the fact that a particular unit of water has less value the more of it there is available, it also has to do with the intrinsic cultural values of how we perceive water and its worth. Which raises an interesting question. On Arrakis, the desert planet, is the spice the most valuable commodity, or is it the water? With that, thank you for listening to this presentation. If you're interested in learning more about the work that Isle is doing related to water reuse, or you just want to geek out about still suits, feel free to shoot me an email. With that, Joe, back to you.
Thank you, Reshmina. Wasn't that brilliant? And I love the fact that science fiction is a route into science interests, even science careers, for lots of people. It makes perfect sense. I wanted to be a biologist in large part thanks to programs like Sir David Attenborough's Life on Earth and Blue Planet. So to learn that a totally different genre of programs is doing the same for other people, I think that's terrific. Outside of Frank Herbert's world of fiction, our next sector expert is also working to improve people's access to water. Shilpa Alva is a chemical engineer and a businesswoman by training whose early life showed her the impact of inequality on access to water. Shilpa's sense of justice eventually led her to start up Surge for Water, to work for water, sanitation and hygiene. Last month I had the pleasure of meeting her online, and here's what she had to say.
Thanks for having me, Joe. My name is Shilpa Alva, as you just said. I'm the founder and executive director of Surge for Water. This year, we're celebrating 15 years of Surge. So it's a long journey. Started, when I was a young girl. I grew up in Dubai, and I would travel with my grandmother and extended family to India every year. And I saw at a very young age that that I was growing up in privilege in comparison to some of the poverty I would see around me. And I always wanted to do something about it. But as a child, I didn't know what that would be, and I didn't know how to do it. But that feeling, that fire stayed within me, and it just kept growing. And eventually, 15 years ago, after a long journey through the corporate world, I eventually founded Search for Water. And our organization is focused on working in partnership with rural, remote communities and local leaders in those communities to deliver their solutions for safe water, sanitation, hygiene, and menstrual health.
Specifically, what does Surge do? What's your aim and what's your purpose and your raison d'etre, and how do you do that?
Yeah, that's a great question. Billions of people right now lack access to basic human rights, right? Like toilets, water at homes, soap to wash hands, menstrual products. And what we do is in the country, so we're working in 4 countries right now: Uganda, Haiti, Philippines, and Indonesia. And in each of those countries, we are in a very specific geographical area. It's rural, it's remote. It is typically where no other international NGOs are working. And what we do is identify local leaders who have their own organizations and have their own vision for how they want to transform those communities. We are only supporting local organizations who are from that community, from those districts, from those communes, depending where you are in the world. And they're integrated there. They were born there. They went to school there. They have grandparents and elders, right? So they're really deeply
actually belong there. Yeah.
They speak the tribal languages. There's a lot of indigenous communities, right? They belong to those tribes, and they don't, have, even if they leave, people have different intentions. They have a deeper belonging that goes both ways within those communities. Yeah. And we're working with them as trusted leaders. They already have gained that, but they've just lacked resources, right? They already have the ideas. They know how to solve these issues, right? We're doing simple things. The innovation comes more from a process standpoint, but the technologies are really adapted towards what can they find locally, build locally, has local engineers and technology that can easily be fixed, can be maintained. And I always say, drilling the well, building the rainwater harvesting system is the easiest part. Yeah. The part that's harder is everything that goes in before and after.
After, absolutely. No, I'm with you 100%. What key success are you most proud of? And tell us a bit about it.
Honestly, just reaching 15 years as an organization and having sustained impact in the countries we worked in, right? So for example, in Uganda, we've been there for 10 years. We're celebrating 10 years in the districts of Kabramaito and Kalaki. And the local partner that we work with, they call Popo, they have been elevated to such an incredible point of success or honor in this community because they've done so much with those local governments. And that's what gives me pride. Not that Surge is recognized in this community, but this local organization has so much respect because of the work we have done together. And, there's over 200 water sources, right? Like 70 or 80 toilets, like almost 200,000 people, maybe even over 200,000 people reached in these two districts. And now we're at the point of like looking at neighboring districts, not just because we want to expand, it's because we have growth-minded partners who have the vision to scale themselves, but also because the neighboring districts in this area are coming to us and saying, please come here as well. So,
and that's the highest compliment. Yeah, if people see something their neighbours have got and they want that too, then I cannot think of a better accolade for what you've done. That's fantastic. What would be your takeaway messages for the audience? So somebody's watching this and going, this is amazing and I want to be involved. What kind of partnerships are you looking for? How do people get hold of you? What do they do next?
We can go into more districts. We can go into more countries if we had the resources. So if anyone in the audience is in a position, personally or through their companies, from a corporate perspective, to partner with us, we have several incredible success stories of companies who partnered with us over multiple years at different scales, right? You've had companies who like every year we're like, okay, we're going to do holistic water, sanitation, hygiene solutions for a school. And each year they do one. We've had others that do it at a much larger scale, where it's like, water systems for larger areas and over multiple countries. And, we have enough experience of customizing the recognition and, the package that comes with that kind of partnership. And yeah, just if we had more of those kinds of, well-intentioned partners who really want to make sustainable change in the right way, we would love to have that conversation, work together to do this.
Fantastic. So any billionaires in the audience, then please step forward. But since every little helps, you don't have to be a billionaire, and please step forward anyway. Amazing.
Hearing from all the billionaires and everyone else too.
Brilliant. Thank you so much for joining us. I really appreciate it and I love what you do. Thank you, Shilpa. This topic is super important to me because where I live, Southern Africa, is littered with the carcasses of dead water projects that were very well meant, but sadly not very well informed, so were not practical in the long term. If this resonates with you too and you want to help, check out Surge for Water's website or contact Shilpa directly using the links shown on the screen right now. Creating water from wastewater is one thing, and closely linked to that is creating other things of worth from wastewater. The term hydrothermal carbonization might sound as sci-fi as a stillsuit, but it's as real can be. Technology company Onunda is using hydrothermal carbonization to generate chemical energy in the form of gas and fertilizer from sewage. Onunda's CEO is Tom Sampson, an energy engineer from Scotland in the UK, who recently had this conversation with Dr. Piers Clark.
Wonderful to be connected with you again. I think we last met, it was months ago, wasn't it? It was at the WWT conference in London. Is that right?
In February in London, yeah. That's the last time we met.
Where's it gone? Anyway, Onunda, what a great name. Am I pronouncing it correctly? And where did it come from?
Yes, you've got it spot on. Onunda. Its name it's actually the Norse origins of how they named Windermere when the Vikings came to the UK. It means something along the lines of Great Lake or something along those lines. And Windermere is our origins. One of our shareholders lives in Windermere, and he had a technology company that he tasked with trying to tackle the sewage problem. And he basically asked the question, why can't we use technology to turn sewage from a problem into something that's got value? And so our origins come from Windermere, and so we thought we'd use that in our name. We're based in the Northwest. Our office is up in Cumbria, so that's where we came up with Onunda. So kind of quite an international name. It sounds nice, and it does stick with you after a while once you get the hang of it.
And when you say Northwest, you mean the Northwest of the UK. It's one of the most beautiful parts of the UK, in some ways, the Lake District. All right, I've got it. Now, before we talk about the actual technology, tell me why. Why are you doing this?
Well, I think our purpose and our mission is really to try to transform how sewage and biosolids are dealt with in the industry, to try to effectively eradicate the environmental impacts that arise from the treatment and disposal of sewage and resultant biosolids. So that's really our purpose. It's to create a much more environmentally sustainable way for how we treat sewage and effectively extract all the energy, value, and nutrients that we can from the sludge and the sewage, such that there's nothing left that has to then be dealt with as a problem back in the environment.
So I've seen a graph, a Venn diagram, very clever Venn diagram with 3 balls. Just walk me through that.
Yeah, this is a Venn diagram that comes from the UK Bioresources Strategy that was issued last year, July 2023. And what it shows is the trends where regulations, global trends, are moving away from traditionally returning biosolids back to land or incineration. And there's a demand, there's a drive for this green circle here is new technologies and innovative ways in how we can treat sewage and sludge. And Onunda, we see Onunda sits clearly in that green circle.
And it's that green circle where it's treating them and them not going to agriculture, not being recycled to agriculture.
Yes, so the green circle is where you've got solutions, technologies that neither have to return the biosolids to land for agriculture, nor incinerate them or return them to landfill. So that's the space. And we see there's quite a lot of opportunity in that space. There are not any other solutions that we're aware of today that fully extract all the energy, value, and nutrients and have zero resultant byproducts going back to the environment.
All right, now we've got a sense of what it is, where you fit and why you're doing it. Talk me through the actual process. So what is the Onunda process?
So the Onunda process really is combining traditional technologies that exist today, which is really our dewatering and drying technologies with our specific gasification technology, with innovative, more advanced technologies on the front end, high temperature destruction, high pressure environment, hydrothermal carbonization, of treating the sludge such that we can destroy the forever chemicals and microplastics and the pathogens under pressure and temperature. And so it's how we combine those 3 processes in an integrated manner where we maximize the recovery of energy and heat between those 3 systems, and we produce byproducts that have got a value or a worth that can be used in other applications. So that's essentially what Onunda does.
And those byproducts are?
So the first byproduct is when we do the dewatering stage, we've created a high nutrient liquid, which is basically free of any plastics or micro chemicals or pathogens. PFAS, yeah, exactly. It's free from all that, but it has some nutrients in it. That can have 2 applications. That can be fed back into anaerobic digesters to boost biogas production, which is a really exciting opportunity if we're integrating this with existing wastewater treatment facilities. Or it has other applications given its nutrient level for hydroponics or other fertilizer applications. The next byproduct is the syngas. Now, most of the syngas is used to heat the process as combustion energy. So all the energy needed for Onunda technology is coming from the syngas released from the sludge.
Okay, so it doesn't need any external energy source.
No external
no hydrocarbons need to be burnt in the production of these byproducts.
None whatsoever. And so we've again produced residue from the gasifier then, where we've produced the syngas that has applications as a supplement for making cement, supplement and manufacturing additive for making bricks, but also has still a lot of nutrients in it. And at this stage, it's a dry, soluble powder. So it has phosphates and nitrates, so it still has a fertilizer application, but in a much more manageable and controllable manner than sludge in itself. And clearly then we have excess syngas, and that excess syngas can be used to provide clean electricity, and that can actually power most of the heat, the energy load, the electricity demand for the wastewater works as well on top of that. So it's a very, very sustainable and environmentally friendly and emission-free solution.
Excellent. Now, tell me, where are you at in your journey? You haven't yet got a full-scale installation, is that correct?
So our first approach is to put in place a pilot project. Now, we've got high technology development on the dewatering and the gasification technology. That's been built before. We're working with Newcastle University on the R&D for the hydrothermal carbonization that's customized for the sludge to create the char for our gasifier. So that piece of work is underway with Newcastle University. But we're now looking at a pilot project application that's about 1/10 of the commercial scale. And that pilot project will be funded by Onunda. We're in the process of raising capital at Onunda right now in the form of a loan. We're pursuing loans that are impact funding for companies that are having a positive impact on the United Nations Sustainable Development Goals. So once we've secured that funding, we'll be in a position to finance our first pilot project. And we're working with counterparties in the Middle East on that first pilot project being deployed as soon as that funding's available.
Brilliant. Tom, I wish you the very best.
Thank you, Tom and Piers. So, destruction of microplastics, destruction of PFAS, production of synthetic gas, syngas for power, and production of nutrients for agriculture, all powered entirely by renewable energy. We will be following Onunda's pilot projects with great interest, and of course we'll ask Tom back for an update. And for this month's And Finally, we're talking big, bold ideas. The 2024 water climate discussion is all about radical change, so step-by-step improvements are good. But when was the last time you saw something truly disruptive? The water sector, the world, is unlikely to meet climate change targets through incremental changes alone, so we want to start discussing the unthinkable now. What radical changes could really move the dial? Non-potable water supply, non-liquid sewage collection, sponge cities, bendy rivers, the polluter actually paying. We want to invite you to propose ideas for radical change. I'll tell you how in a minute, but first Piers is back with his radical idea.
Okay, so here's my suggestion for the water climate discussion, and that is we need to go away from mixing poo with water and flushing the problem away. We've got to get back to dry toilets. We've got to get back to composting toilets. And the technology has moved on in leaps and bounds in recent years. It isn't such a big problem technically to deal with. It is a big problem to deal with socially. And just when you're thinking that it's an impossible problem to solve, well, come with me on a journey. Let's go back to the 1980s when if you walked the streets of the UK, you'd have found dog poo everywhere. It was a horrible problem. You'd get it on your shoes and it was just horrendous. Everybody knew it was a problem, but we couldn't get past it. Felt like it was an insurmountable problem. Here we are today, no dog poo, and what you have is little old ladies walking around, walking their dogs and carrying a bag of dog feces with them. It's almost a pride thing now that you carry your dog feces to show that your dog didn't poop. We've got to get that same sort of societal shift with our approach to wastewater. We must stop flushing poo away with water because the energy that we need to spend on separating it back out again is just preposterous.
Thank you, Piers. And everyone, all you need to do is grab your phone and record your radical idea. Post it on LinkedIn with hashtag radical change and @mention water climate discussion to get the debate going. So please jump in. Share any ideas for radical change that you have. There might be unpopular ideas that you wouldn't want to try, or big changes you think we should already be making. With that, we come to the end of this month's Water Action Platform. Once again, I would like to thank all of our fantastic sponsors and, of course, today's contributors. Next month, we will be taking a closer look at pharmaceuticals in the environment and what we can do as individuals and together as an industry. I hope you can join us. Until then, keep asking questions, keep sharing, and keep safe.